Okay, something you've done a lot, right? We're going to classify them by their sides and their angles. There are three ways we classify them by sides. Is anybody, probably the one you guys actually don't know, it's the first one. What does it mean when a triangle is scalene? What does congruent mean? Same size, correct? What other type is there? Isosceles. I always misspell that for some stupid reason. You ever get a word stuck in your mind backwards? You tend to always make that same mistake. I always try to put the C in the first instead of the second. What does it mean to be isosceles? And this is an important part. At least two sides are what? Congruent. Third one. Equilateral. What does this mean? Okay. Those are the three ways we are going to, label them by their sides. How about the angles? Do you guys remember how we do that? How do we do that? A triangle can be acute. What does that mean? What it means is that all the angles are less than 90 degrees in measure. This is actually the only one where we're talking about all the angles. Because with a right triangle, what does it mean? One angle is what? And then the third one, which is what? Obtuse. One angle is what? Greater than 90 degrees. Those are our different types there. Okay, and this is all should be a review. You should have dealt with this in some way, shape, or form in other math classes before you've gotten to us. Now, what we're going to go into more detail with in this section, in a little bit more detail, we're going to talk about isosceles triangles. Has everybody got this down? Can I move up? Okay. An isosceles triangle. That is a triangle where two of the sides are what? At least two of the sides are congruent. Question to you guys, is an equilateral triangle an isosceles triangle? It is, isn't it? Oops. Now, these two sides are special. You know why? You know what they're called? Nope. They're called the legs. Can anybody think of a clever way why maybe they called these the legs? Yeah. If you spread your feet apart, does your lower half make an isosceles triangle with the ground? What are the two congruent sides there? Your what? Your legs, right? You understand what I'm saying? You know, you're standing here like this. Most people's, and of course not all, legs are the same length, aren't they? Agreed? And the ground, what do they make? Your legs and the ground make a what? Isosceles triangle. Hence why they call it the what? Legs. If you're trying to keep them straight, and that's why that's a good name for that. It's not probably the only reason, but it's a good reason. Now, what is something you stand on? You could call it the ground, but the legs are standing on a base. So guess what that third side is? The base that the legs are standing on. These are called, these angles, base angles. They are the angles. They will always be congruent, because in a triangle, if two sides are congruent, the opposite angles are congruent. Something you'll learn later. This point right here is called the vertex of an isosceles triangle, or the vertex angle, because it's where the legs meet. It's where the things that make it an isosceles triangle start. So that's the vertex angle. Questions on that? It's not too horrible, is it? Never heard anybody talk about why the legs are legs before, did you? Does everybody get that worksheet out? Are we ready to put the worksheet up here? Okay. First of all, let's kind of identify the problem we're dealing with. Part of the reason why I have you guys write the problems. I want you to say to yourself, okay, this is my situation. And so I have you draw the figures as well. Our situation is this picture. And in our situation, refer to the figure at the right, triangle ABC, that's this triangle right here, correct, is isosceles, with AB being greater than AC. So this one is bigger than what? So and AB is also bigger than BC. So if it's isosceles, which one are my congruent sides? What, the two bottom ones here? These are my things that make it an isosceles triangle. Because if this length is bigger than that length, everyone look up here, don't write. If this length is bigger than that length, then they can't be equal, can they? And they said it's isosceles, so I know two of these sides. Really, you didn't need the second one, did you? Because once they told you that these two weren't equal, what were the ones that had to be equal then? This one and this one, right? Everybody with me? Okay. Also, XY is parallel to AB. So these two are parallel. Well, the reason they did that is because now I have transversals. I can say that angle is congruent to that angle, can't I? This angle is congruent to that angle. Okay? And these two are congruent to each other because in an isosceles triangle, your base angles are always congruent. Remember that. In an isosceles triangle, your base angles are always congruent. All right, name each of the following, the sides of the triangle. What are the sides of this triangle? AB is one of them. Is that correct to write it like that? No, it's not. Why not? That's the distance from A to B. If I'm talking about when naming a segment, naming that thing right there, I have to put a segment above it to say segment AB. If I just put AB, I'm saying I'm talking about whatever its length is. That's why these up here, that's okay. That's why these up here are talking about something being greater than the other. That's a number, actually, isn't it? So AB, what is, okay, we've got that side. What's another side of this triangle? I heard, did you say BC? Segment BC, so I put BC and then I put a segment above it. And then the last one, AC. Easy peasy, right? How about the angles of a triangle, of the triangle? This could be a little tricky. You have to remember how to name these. This is back in the first chapter. And this is something that repeatedly we need to keep harping on. A lot of you, I'm starting to notice on our homework, and even in all my other classes, are starting to cut corners, and we need to stop doing that. Because you've got to be able to speak the language, because what will happen is when you get into more complicated stuff later on in the year, the language will confuse you because you won't know what they're asking because you haven't been writing it down correctly the whole time. Okay, the angles of this triangle. Now, there are three angles. There's this one, and this one, correct? Can I name that one angle A? I can. So I can say angle A. Can I name that one angle B? I actually can. Because that's the only angle I'd be talking about. Now, can I say that's angle C? Why? Right. You wouldn't know whether I was talking about this angle, or this angle. So how do I need to name it? Angle, and you need to put that there, what? AC, what? B. Very, very important here. This is something we need to review and remember. Okay, which one is your vertex angle? Huh? But can I call it that? It's the vertex angle because isn't this where our two legs meet? What are our base angles? What's the side opposite angle? BCA. BCA. What's the side opposite it? What is the side? So it's going to be what? Two letters with a segment above it, right? Opposite BCA. So which one's opposite that angle? AB. Okay. Number 6. What are my congruent sides? AC would be congruent to segment what? Very good. Which angle is opposite AC? Which angle? So, which angle is opposite AC? B. So how should I put it? Angle B. Make sure you put zeros in for once. But, don't have them. Any questions on that? Let's look at number 8. Classify its triangle by its angle and by its sides. Okay. First of all, by its angle, it's a what? Now, did they tell you any sides were congruent here? They did not, did they? So it's a right what? Scalene triangle. You use both words because the angle can affect what you get for the sides, but they're two separate classifications, so we're going to say each classification every time.
Do we have to draw the triangle? Like,
No.
okay.
Now, I think there's a misprint here. For some reason, there is no triangle here, so how about I draw a nice, pretty one? Any questions? What do you think this one is? Why? Because it has one angle, what? Greater than 90. Did I indicate any sides being congruent? Scalene triangle. What's that one going to be? It's acute, equilateral. You don't have to say acute isosceles equilateral. By saying equilateral, you know that it's what? Isosceles. Okay? It's acute equilateral triangle. That was a joke. You're supposed to laugh now. You know, LOL doesn't work. You have to actually laugh out loud when you're around someone. Anyhow, find the measure of legs of isosceles triangle ABC. So let's draw us an isosceles triangle A, B, C. Okay, so this is, I'm going to make this my two congruent sides, okay? So, well, we really don't even know. A, B, C. Find the measures of the legs. I actually don't know which ones are congruent right now by what they've given me. Okay? You understand why I say that? Because they didn't tell me which one was the what? Vertex, which ones were the base angles, all this. All I can do is just write down the information they give me, and they have not given me, which ones are congruent here. So AB, what did they tell me the length from A to B is? Okay. What did they tell me the length from B to C is? Everybody just stop. Put your pencils down. I would like you to stop and watch me do this problem. Everybody sees that AB is 2x plus 4, correct? That's why I'm labeling here. BC is 3x minus 1. What is AC? Now, I don't know whether this one's equal to that one's equal to that one, or what. Agreed? So I can't use that as an equation. Remember, if it looks like algebra, I probably need to create a what? Valid what? Equation. This is a big part here. But what they say here is that the perimeter is what? 34. Now, remember, you guys remember what perimeter is? It's simply around, if you were to walk from A to B to C back to A, however far you walk, that's the perimeter. So whatever this distance is plus what? Whatever that distance is plus whatever that distance is gives me my what? Perimeter, correct? So if my perimeter is 34 That's equal to all these sides added up together, isn't it? You know what A to B is plus whatever what B to C is plus whatever what A to C is. That's my perimeter, isn't it? Well, what is A to B? What have they told me it is? You guys see why I'm putting this in here? Everybody okay now? Okay. Zoom out a little. B to C, so plus, what's B to C? 3x minus 1. Plus, what's A to C? Isn't A to C x plus 1? Don't these represent those distances? Everyone agree? Now, so you've got an equation now, don't you? And I have one type of unknown, so I can solve for it. Is this a big, ugly, scary-looking equation? It is kind of big, ugly, and scary-looking. When I taught algebra, I always told guys, hey, when an equation looks really weird, most of the time there's some simplifying to do. And there's a simpler way to write it. Is there a simpler way, you know, are there any like terms to combine here? Yeah. The simpler way to write 2x plus 3x plus x is to say 2 and 3 is 5, and then one more makes what? That's a much simpler way to write that, isn't there? And then how about the numbers? 4 minus 1 plus 1 plus 4. Now does it look as scary? Does not, does it? Stop writing. Watch me do this problem. You can write it down after we're done. What's my next step? Now, why does this help me? What did it ask me to find the measures of the legs? This helps me because if I know x, I can plug x in and see what all of them are, right? So I need to solve for x here. Well, if a 30 is equal to what? 6x. What am I going to do now? What's x equal to? Okay, we found x. Are we done? In a multiple choice test, should I just find, you know and how mean they are on SAT tests and regular tests. What's one of the answers definitely going to be in this problem for A, B, or C? Yeah, they're going to put 5 there. And you're not wrong. X is 5, but is that what they asked for? They asked for the legs. So what I'm going to do is I know that this side is 2 times what? Whatever x is plus 4. What is x? I know this side is 3 times whatever x is minus 1, and x is 5. And I know that this side is whatever x is, which is 5 plus 1. So this one's what? 6. This one is, and this one is what? So which 2 are my legs? So the legs are what? 14 units. 14 is your answer, is it not? You think if you had this problem and all you had is 14 as an answer, you think you can get any credit? Even if you wrote the problem down? No. I'm sorry, you didn't do that problem. You cheated, or you did it from back of the book, you copied from somebody, or you just decided to pick a number between 1 and 20 and got lucky. If so, that's nice and all, but homework is practice. I'm trying to educate you guys. I'm trying to help you learn the material. I want to see what you've learned. And if you just put an answer there, I'm assuming you haven't learned anything. There's no reason to write it on a different sheet of paper either. I'm really sick of seeing 1 through 10. Start skipping some lines in between. Huh? Yeah. Just do a problem one at a time. And then if you don't know how to do it, skip it, leave space, and go on to the next one. In this assignment, there are there's one problem that asks you to use algebra. I promise you that's 40% of the assignment. 40 to 30% of the assignment. And you better show every step doing it. Okay?